Let's get started creating a project and a small application. I'm going to start by opening IntelliJ and saying Create New Project. I'm going to choose Kotlin and Kotlin JVM because we're creating a project that compiles down to JVM bytecode as opposed to JavaScript. Also, in a more real-life scenario, I might be using Maven or Gradle as a build system. Those are similar to Ant. But for a simple application, we're really just trying to learn the basics of the language, so we'll focus on just using IntelliJ by itself without Maven or Gradle. So I'm going to say Next. I'll name this Kotlin for Java Developers, KJD. I'll accept all the defaults and say Finish. And it creates a little shell of a project. The first thing I'm going to do is the same thing I would do in a Java project. I'll create a package to put our stuff in. So a package is basically a namespace. I'm going to call this package KJD, Kotlin for Java Developers, KJD. And so it creates a folder. So in general, in Kotlin, packages correspond to folders, though they don't have to. You can create packages without creating folders. I'm going to create a new file here inside of our package. I'm going to choose New Kotlin File /class. And I'm going to call this main. I don't have to call it that. I'm just choosing to call it that. Now, the first thing to notice is it creates a package declaration just like in Java, but without the semicolon. So you don't need semicolons in Kotlin. Before I create our main function, let me create just a simpler function. I'm going to say function f1, open paren, close paren, open curly. There's your simplest possible function ever. So as you can see, it starts with the word function. If I don't specify a return type, it returns void, or actually a unit as it's called in Kotlin. Also, if I want to put arguments in, I declare them like this. I'll say x int, comma, y int. So a few things to note. In Kotlin, the variable name comes before the type. Also, you'll notice we have integer with int with a capital I. So in Kotlin, we don't have a int with a small I as something distinct from integer with a capital I. We just use int. All right, let's actually make this a proper main function. So to do that, it has to be called main, and it takes one argument representing the command line args. So we'll call it args, and it's of type array of string array. All right, another thing to note is the type here is array of string, and you'll notice that array is just a regular class, a regular type in Kotlin. So there's no special syntax like using square brackets like there is in Java. So the way you declare a variable of type array is just like this. All right, now let's print out our hello world. So we'll say println hello world. So again, no semicolon. Something else to note is that in Kotlin, you can have top-level functions. That is a function that is not inside of a class. So this function is in a package, it's in a file, but it's not in a class. I did not have to create a class to hold this function. All right, and I would say top-level functions are something I use all the time in Kotlin. So there's our simplest possible hello world. Let's run it. So I'm going to right-click right there and say run. And there it is. There's our hello world. All right, before we wrap up hello world, let's cover a few little basics of Kotlin. First of all, how to declare a variable. There's really two ways to declare a variable. One is by saying var x int equals 10. So there's one way to declare a variable. And here's another way to declare a variable. Val y int equals 10. So notice I don't have a semicolon. Okay, a couple things. One, var creates a variable that can be mutated or changed. So in other words, it's a variable just like a variable you're used to. Val creates a variable that cannot be changed. It's immutable. It's kind of similar to saying final in Java. So in general, I recommend using val for pretty much everything, unless you know for certain the variable needs to change, and then I would use var. Another thing that's neat about Kotlin is this. Kotlin is a statically typed language like Java. That means every variable, every expression, and every function return has to have a type declared at compile time that the compiler can figure out at compile time. However, you don't have to explicitly declare that type. So I'm going to go like this and get rid of the int. So if Kotlin can figure out the type or infer the type, then you don't really need to declare it. So since I initialize this variable with a 10, Kotlin is smart enough to know that x is an int. Same thing here, I don't need to put the int in here. So type inference is a major defining feature of Kotlin, and it's not to be confused with dynamic languages like JavaScript. In those, you also don't have to specify the type. However, in Kotlin, it is a statically typed language. It's just that the type is inferred. So a statically typed language with type inference is really not the same as a dynamic language like Ruby or Python or JavaScript. All variables and expressions and functions have a type as determined at compile time. All right, so that's type inference. Okay, so let's kind of summarize all the things we've learned. We learned that Kotlin has packages just like Java, except you don't need the semicolon. We learned that Kotlin can have top-level functions. We learned in Kotlin that the variable name comes before the type. We learned that arrays in Kotlin do not have any special syntax. It's just a class name, just like a list or a string. We learned that there's a println function, which is a global function, so you don't have to say system.out like you do in Java. We also learned that you have two types of variables, a var and a val. Vals are immutable, vars are mutable, changeable. And finally, we learned about type inference, which means in some contexts, you do not have to explicitly state the type because Kotlin can infer the type of your variable or expression based on the context. As we progress through this course, we will learn more about when you have to declare the type and when it is optional. All right, I think that's enough for our lesson 1. Let's wrap right here.